it's very hard, has two major branches. Differential calculus and integral calculus. So what is the scope of calculus in JEE? The calculus is the most important topic as far as marks are concerned as per weightage. It accounts for around 20% of all questions of all marks given out in JEE. But that's more of the direct weightage. Even indirectly, in your physics and in your chemistry, calculus does tend to rear up its head somewhere or the other. So what type of questions can you expect in calculus? You have both easy questions as well as a few hard questions which can be expected from this section. Quite a few of them involve very subtle variations which can give you an answer in the click of a hand. Now, all subtopics of calculus are equally important in JEE. None of them can be ignored. None of their importance can be discounted. So let's look at the elements of calculus. You have functions, limits of functions, continuity and derivability or differentiability, methods of differentiation, applications of the derivative, integrals and their applications, and differential equations. So what are your basic problem solving strategies? What exactly should you focus on when you solve problems related to calculus? Now, finding the domain or the range and functional equations are the most common types of problems in calculus. And in calculus, the subsection of functions, these are the two types which you'll be encountering mainly. Domain evaluation only requires a careful examination of each portion of the function. And finding the range is again rather basic. Domain and range considerations here aren't very difficult as such. Again, you just need to be careful with what you're doing. You just need to keep your concentration levels up. And there is no question as to why you make any error at all. Functional equations on their own do not have a standard procedure of solving them. But putting certain values of the variable gives some information about the function. For instance, if the relation involves x and y, put y equal to minus x or say y equal to 1 upon x and so on, and these might be useful to you solving your problem correctly. Let's go on to limit evaluation. Limits are again not very difficult as such. Limits are usually simple and they involve either standard limits, binomial identities or trigonometrical identities, with the only complications arising due to tough to simplify functions. Again, you could have manifold combinations of functions, but the essential idea of taking out a limit at the end of it is very simple. All the complication is involved in simplifying the function. Now, in such cases, the approach should be to take this expression out part by part, to dissect it, and to ensure that every single part simplifies to a final simple expression. If it doesn't completely transform into combinations of standard limits, it probably involves the application of theorems such as Sandwich theorem. Also note that you should try and memorize expansions of all standard functions. This is going to save you a lot of time in your examinations. You would not want to go into your exam and evaluate the limit of sin x or cosine x, because there is just not that much time while you're solving your examination. Now, L'Hopital's rule, the limit f of x upon g of x as x tends to 0, if your denominator is 0, and the numerator tends to 0 as well, the 0 by 0 form. So that can be transformed to f prime x by g prime x limit as x tends to 0. So this rule again finds a lot of use in many questions. But again, be careful about all these conditions that is stated, that the 0 by 0 form should be existent and x should tend to 0. Let's go on to more basic problems in continuity and differentiability or derivability. Now, continuity and differentiability are at their very core very simple applications of limits. You go to a function from the left hand side, you go to a function from the right hand side. If they meet at the same point, the function is continuous, otherwise it is not. You take the derivative from the left hand side, you take the derivative from the right hand side. Should the derivative be the same, the function is differentiable, subject to it being continuous. There is nothing more to it as such. Just remember the very basic definitions of limits, and of course, the limits of standard functions, we reiterate again and again, should be on your fingertips. Now, in such cases where you encounter functional equations involving continuity and differentiability, apply the basic definitions of continuity and derivability and use the given relations or equations to evaluate the derivative or do whatever is asked in the problem. Now, apart from these, there are a few important theorems in continuity and derivability. These include the intermediate value theorem and the mean value theorems, and there are many offshoots and corollaries. Generally, it is quite easy to guess if a question involves one such theorem. As a variety, inequalities may also result from these, but these again are generally very easy and won't require a lot of consideration from your side.